All right, so for this video here, what we're going to be doing is we're going to be finding the volume of shapes that are generated by taking a region and rotating it around an axis, okay? So what I want to do first is I want to do an example problem that isn't on your homework. So let me pull that one up. Looks something like this, okay? So let me explain what's going on this problem here. Okay, so what's going on right here is I have this region that's been created by this parabola right here and this horizontal line, and it's being rotated around this axis of rotation right here. So the horizontal line y equals -2. So if you can imagine, what would happen is you rotate this around this axis. Okay, it's going to be like, gosh, these are kind of hard to explain. It's going to be like I don't know, almost like a donut type shape. We're going to have a big hole in the middle, okay? So, in fact, let me do this. Let me try drawing the counterpart here. So as this gets rotated around, so this line gets rotated to there, and then count down 4. So this would be like, let me shade that in. Okay, so this would be a cross-section of this shape. So it's basically, if you're looking at from the top down, you would have, kind of a donut shaped. This is just, being sloped down. If you look at it from the side, this is what you would see. You would see something like this. Okay, and you can't tell, but there's a big hole right here in the middle. Okay, that's what the three-dimensional shape looks like. We're trying to find the volume of that shape. Okay, so let me erase those right there. What we want to do is I want to look at this kind of a piece at a time. So let me get rid of that shape. Actually, we'll keep it. Let's keep it. So what's happening here is I've got two curves. I've got this curve right here, and I've got this one right here. So I just want to focus on this one first. As it gets rotated around, it creates this shape right here. So imagine that all the way filled in with red. That's the shape it creates. So right here, what we're looking at, so if I draw straight vertical lines like this, what these represent are going to be these slices. Like if I were to take a knife and just slice this three-dimensional shape down like this, and I were to look at them, each of those slices represents a circle. So we have really smaller circles up here, bigger circles down here. So it's just a whole bunch of circles stacked on top of each other. So when I find the volume here, what I want to do is I'm finding the volume by finding the area of these circles, pi r squared, and adding them all up. All these circles are stacked from an x value of 0 to an x value of 2. So they're like pancakes, just tipped on their side. So I'm adding these areas all the way up from 0 to 2. So I need to come up with a way to do that. So what we have is, if I'm adding things up, that's going to be integration, and I'm adding up areas, pi radius squared. Okay, question is, what is the radius? Because as you can see from this picture, in fact, let me erase like this blue part down here. As you can see from this picture, because the circles are different sizes, my radius is changing. Okay, so my radius of, say, like this point right here, as it gets rotated around, it creates this slice right here. Okay, and the radius is that amount right there. Okay, this point up here creates this right here, that slice, and that's the radius right there. So these radiuses are different sizes. In fact, the further I go along here, so these are all radiuses, so come straight down, right? These are all radiuses. The further I go that direction, the smaller my circles go, the smaller my radius gets. So my radius is changing. So here's how we figure out the radius. Okay, it's simply your equation, so we're going to call it the top, okay, minus the bottom. How is that region that this region right here, defined? So the top is my parabola, this negative x squared plus 4, so negative x squared plus 4, and the bottom, so minus the bottom is this axis of rotation, which is -2, so I plug in -2. So what this gives us here is I've got this amount. Okay, so let me come over here. If I plug in, let's do that middle part again. Okay, remember my goal here is to get this distance right here, because that's my radius. Okay, so if I go right on that same x value, and if I plug that x value, what is it, 1, into this equation, 1 squared is 1 times a negative is negative 1 plus 4 is 3. I get that amount right there, which is not enough. Right? It just goes down to the x-axis. I need this extra piece right here. Well, that extra piece, negative 2, I can't just add those together because this is a negative 2, this is a positive 3. If I add those together, positive 3 minus 2 is positive 1. I don't want positive 1, I want 5. So what I want to do is I want to subtract that bottom equation. So if I subtract that, now I get 3 plus 2, which gives me my 5. So this, and then if I integrate, these pieces are being stacked from 0 to 2. So if I integrate that from 0 to 2, these are all x values, so dx, dx. This right here is going to give me my volume of the shape generated by my outside curve. So this is for my outside curve. I kind of ran out of room. Outside curve, okay? So it's this shape right here. So there's that piece, there's half of it, and then I come down and there's the other half of it. So the volume, when I type that in my calculator, which I'll do in just a second, that will give me the volume of that. Okay, so after I type this in my calculator, I get 145.7699. Okay, so 0.77, right? So that's the volume of the whole thing, but I don't want the volume of the whole thing. So if you look at this shape right here, so let me come back to my blue, the shape was only this part right here. Okay, this whole interior part, I don't want that. So what I need to do is I need to subtract from this a portion of this red one. So let me erase this. And let's talk about this interior part. So we talked about the outside line. Now let's talk about the inside part. So I'm going to do this with green. Okay, so this line right here is the inside part. And as it gets spun around, creates that. And if I find the volume as this gets rotated around, I get this shape right here, which is exactly what we want to get rid of out of this piece right here. So we are making, once again, circles. Okay, these little lines are cross sections, or these cross sections are actually circles. Okay, the radius, that amount right there, is simply we're making circles, we're adding up the areas, pi r squared. The radius is my top, which in this case is the line y equals 2. No, it's the x-axis, sorry. It's the x-axis equals 0, so y equals 0, minus the bottom, which is the axis of rotation, which is negative 2. And if you look at that, 0 plus 2 gives me a radius of 2. The radius is 2 the entire time. The entire time my radius is 2. So I'm going from 0 to 2 dx. Type that into our calculator, and we get 25.1327. So this is the piece that I don't want, okay? So I'm going to take this away from that. So 145 minus 25 is 120.637. That is the answer we want. That is the area of our blue shape that we've been working with. As that blue gets rotated around, creates that donut shape, that's our area. So now let's kind of recap what we got right here. I want to find the area of my circles for my outside shape. Okay? So pi radius squared. My shape are circles, so to find the area of circles, that's what I got. My radius is going to be my top of my region, minus the boundary on the bottom. Now for these problems, our bottom boundary is always going to be our axis of rotation. Okay? So when I take the integral of that with our lower bound and our upper bound, this will give me the volume of the outside shape, so the shape created by the outside edge. Now oftentimes we'll have the axis will not be right up against that region, and so we will have a gap. And in that case, I want to subtract the volume of the region, the volume of the shape created by that region. So pi radius squared. This is my inside piece, so like the green one right here. So once again, it's just the top of that region minus the bottom, which is going to be my axis of rotation. Okay, and then if we're dealing with D, if our pancakes are stacked like so, vertically, okay, meaning I'm rotating it around something parallel to the x-axis, okay, then it's dx. If my pancakes are stacked like this, okay, and I'm rotating it this way around something parallel to the y-axis, then it's going to be dy. So it just all depends. So dx or dy. Okay, this is our magical formula that we're going to be using on every single one of these problems. So we'll copy this over to above problem number 1 so we have it forever. So with that said, let's get started with problem number 1. All right, so here we go. Problem number 1. Well, let's first write our equation down. So we are doing, get my pencil. So here we go. We want to take the integral of pi radius squared minus pi radius squared. Okay, this first circle, pi r squared, this is my outside circle. Okay, what's making the outside of my shape? To find the radius, I take the equation that's on the outside, so we're going to call it the top, and I minus the bottom, which in this case is always going to be my axis of rotation. Okay, and then over here I also do top. So this is the bottom, sorry, this is the inside circle, so this is inside. And still, what makes that region, the top minus the bottom, which is going to be my axis of symmetry, or axis of rotation. So let's apply it to this problem right here, okay? So first off, notice I am rotating around the axis x equals 2. That is parallel to the y-axis. So everything in this one is going to be with reference to y. So when I do my equation, okay, it's with respect to y. So my bounds are y's, it's dy, everything inside has to do with y. So let's look at this. So when I rotate it around this, I get this kind of a shape, okay? Here's my stacks, they're being stacked like this. These are cross sections. These are my shape and they are circles, okay? So notice I don't have a hole. This is going to be a solid shape. So watch how this works. So my top, here's my region. It is, so it's pi radius squared. So it's the top part of this region is negative y squared plus 6 minus my axis of rotation, which is 2. Okay, and I like that because if I don't do the minus 2, watch what happens. So I'm going to erase all that crap. Kind of. Eraser's not very big. So if I were to take like this point right here as it gets rotated around, if I plug in 6 into this equation, sorry, if I plug in 0, 0 is my y value. If I plug in 0, 0 squared is 0, times the negative is 0, plus 6 is 6. So I get this distance right here. And notice that is too long. 6 units is too long. I want it to be 4, right? So that's why so this comes out to be 6. I want to minus my axis, so minusing 2, that will get me to 4. So subtracting 2 will get rid of that. And now I've got my correct radius, okay? So that's the outside of my shape. There is no inside portion. So if I were to continue using this same equation, minus pi radius squared, my inside shape, so right here, is 2, that's the line, 2, minus my axis of rotation, which is 2, that becomes 0, that whole thing just goes away. Okay, and that might be a little confusing, I don't know, but I thought it would be nice to use the same equation every single time, whether it has a gap or not. So if it has a gap, use the whole thing. If it doesn't have a gap, you can just get rid of this part because there is no gap, it just ends up being 0. That whole thing goes to 0, you don't need that second part, if that makes any sense. So what we're doing is, I want the integral from our bounds. They're being stacked like this, so I'm going from negative 2 to 2, pi r squared dy. Negative y squared plus 6 minus 2 is plus 4. There's my equation. That's what I'll type into my calculator. And we get 107.2330. So I just keep it like that. And there's problem number 1. Okay, problem number 2. So, same idea. In fact, look at this. It's the exact same shape. Just it's being rotated around this axis, but it's the same shape. It's going to create the exact same volume. Our answer is going to be this. But let's just do it just for fun. Just make sure we did the first one correctly, right? So here we go. I want to take, let's do it up here, the integral. This time we are stacking them this direction. These are my radiuses. We're going from -2 to 2. Okay. The top equation is, so it's pi radius squared. To get my radius, it's top minus my bottom, which is the axis of rotation. So -x squared plus 5 minus my axis of rotation, which is 1. These are parallel to the x-axis, so this is dx. Anyways, type that into your calculator, and indeed we get 107.233 is our answer. Okay, let's look at problem number 4. Or sorry, number 3. Problem number 3. We've got this little shape right here. We're rotating it around this axis. Once again, there's no gap, so I don't need that second part to the equation. You can put it in there if it just helps, but you don't need it. So we are, once again, adding up areas of circles. So pi r squared. Okay, this is parallel to the x-axis. In fact, it is the x-axis. So these are going to be x values. So I'm going from here to here, so 0 to 1. And this is going to be the, let's use a different color. So we're doing, here's my top, and there's my bottom. So the top equation is going to be this cubed root of x. So I'm going to do x to the 1/3, okay, minus my axis of rotation, which is 0. And that's what I'll type in my calculator. And we get let me change my color. We end up getting 1.884 and then a 9. So you can either do the 1.884 or you can round it up to be 1.885, either one. Okay, problem number 4. We've got kind of a similar shape. So we're going to rotate this thing around the y-axis. So since it's parallel to the y-axis, everything is going to be in terms of y. So we're going to take, once again, we're adding up circles. So as this gets spun around, it's going to look like that. Okay, kind of like a Hershey kiss. So we are stacking these Hershey kisses from 0 to 1, and we're adding up areas of circles, pi r squared, with respect to y. My outside is this curve right here, which is y cubed, and my axis of rotation is 0, so minus 0. There's our equation. Now we just type it into our calculator, and we get where's my mouse? 0.4487. So 0.448, or you can round it up to 0.449. Okay, problem number 5. So what we got going here is we got this little shape. It's going to rotate around. It's going to be like a really flat Hershey kiss, or a really flat chocolate chip is what it's going to look like. But anyways, we are rotating around the x-axis. Okay, so this is going to be with respect to x. Okay, whoops. What did I do wrong? dx, there we go. All right, so our equation is going to be, we are stacking these things. So they're being stacked. Let me just draw this picture. Let's see, go down 4. And so that's what the slice is going to look like. So these slices right here, those are circles. So we're adding circles from 0 to 2. Areas of circles, pi r squared. Okay, the these radiuses right here are bounded by this equation, which is -x squared plus 2. On the top and on the bottom is our axis of symmetry, which is -2, so minus a -2 dx. And we can type that in our calculator. If you want to, you can kind of simplify this a little bit first. So +2 plus 2 is +4. So I'd probably plug in -x squared plus 4. Don't do too much work, but that's pretty easy. Anyways, type that into a calculator, and we get 53.6165. So you can do 53.617 or 53.616. Either one is just fine. Okay, number 6. Once again, we are rotating with around an axis parallel to the x. So we're doing dx. Everything's within terms of x. Okay, so here we go. Here we go. Some fun problems. So now check this one out. We have a gap here. Okay, so our region is not right up against the axis of rotation like it has been on the other 5 problems. So we are going to need to subtract a certain volume. Okay, so let's worry about the outside volume first. So let's make our equation. We are dealing with x's. So let's see, this shape is going to look something like, so we come up here like that, and then, so there's our other region right there. Okay, so this is like a cross section. If I would take this 3-dimensional shape and cut it right like that, that's what I would see. Okay, so these are being rotated like this. So with the dx, so our top of our stack starts here at -1, and then it goes to +1. So we're going from -1 to +1. All right, so now here's where we're going to have those 2 equations. So I'm going to do the outside pi r squared of the outside of the shape. So that's going to be this guy right here. As it rotates around, it cuts up here right there, right? This is my radius right there. Okay, so as I do the function itself, so it's going to be, what is this? This is a straight line, so it's going to be -x - 2 minus the axis, so 1. That will give me the whole way that I need. Okay, so there's that. And when I find the answer to this, I get that whole thing right there. Okay, but we don't want this middle piece right here. So we want to get rid of it. We want to subtract it. So minus pi r squared, because it's also being generated by circles. Okay, and this middle piece is bounded by this quadratic right here. So -x squared minus the axis, so -1. And there's our formula. So this will give me the volume of the outside shape. This will give me the volume of the inside shape, and I'm subtracting them from each other. You could also treat it as 2 different integrals if you wanted to, but I don't know, one's easier for me. So that's what you want to type in right there, exactly how that looks. You can do a little cleanup. You could do like a -3 instead of -2 - 1. Can't really do anything over here. You could pull out the pi's and just put the pi on the outside here. That's fine too. Just don't do anything too crazy because you don't want to accidentally mess up, do something wrong with your algebra and then totally mess up your problem. So anyways, we type that into our calculator and we get, let's change back to black. I got 46.9144. So 46.914. Okay, let's look at number 7. So there we go. This time, what do we got going? Okay, it's right up against the axis again, axis of rotation, so we don't need to worry about that second part to the equation. In fact, that looks very similar to a previous problem that we had. The one right above it. Notice it's that same shape right there. So our answer should be 53.616. Guess I need to make a better worksheet. So here we go. So this time I'm rotating around an axis parallel to the y. So everything's going to be in terms of y. Okay, we're doing this with respect to y. So we've got the integral being rotated like this. So they're being stacked from here to there. Right, that's where our stacks are going to be. So we're going from 0 to 2. Pi r squared dy. Our outside edge is -y squared plus 2. Our inside edge, so our axis, so minus our axis, which is a -2. So minus a -2, so that's going to become plus 2. -y squared plus 4. Okay. Anyways, type that into your calculator, and sure enough, you get 53.617. Okay, let's look at problem number 8. So once again, we're right up against the axis, so there's not going to be that middle gap. So here we go. I'm going to run out of room to write. Didn't give you guys very much room, did I? So we are rotating it like so. So our graph's going to look like that. So these are my cross sections. These are my circles. Okay, so we are adding up our areas of circles. Okay, it's parallel to the y-axis, so this is in terms of y. Everything's going to be dy. We are stacking them from 0 to 1, and the radius is going to be this curve right here, so the quadratic curve, -y squared plus 1, minus the axis of rotation, which is 0. And there's our equation. And we type that into our calculator, and we get 1.6755. So 1.675 or 1.676. Okay, problem number 9. This time we do have a gap. Okay, so our region is not right up against the axis of rotation. So we need to do both parts. We need to do, set it up. We've got our outside, pi r squared, minus our inside, pi r squared. Okay, this is rotating around the y-axis, so it's dy. Okay, they are being stacked, so they get rotated around. So it looks something like, I don't know, like that, right? That's really bad. Anyways, it looks something like that. So as they get rotated around, they're rotating it like this. Okay, so they're being stacked from 0 to 1. Those are y values. My outside edge, so that's this guy right here. It is, so I'm looking at that region right there. So here's my top, here's my bottom. So negative y squared plus 4, it's the parabola. That's how I know it's this equation right here, right? This one's a line, which is going to be that equation right there. So minus my axis of rotation, which is 0. So that's nice. And then I got to do my inside. So that's this guy right here. That's the top of the region. And there's the bottom of the region. So I'm talking about this part right here. Okay. So the top part is this equation, negative y plus 2 minus the axis of rotation, which is 0. And there's our formula. So now we just type it into our calculator. And we get 35.1858. So you can do 35.185 or you can do 35.186. Either one would be correct. Okay, problem number 10. Once again, we've got a little bit of a gap here. We are rotating around an axis of rotation that's parallel to the y-axis. So this is going to be in terms of y. So everything's going to be a y value. Okay, so we're going to have, we are stacking these things. So let's just see what they kind of look like. So that's the other part of it. Okay, so as it rotates around, it kind of creates that shape, and it's, you know, three-dimensional, like a ring or something. But when I rotate that shape, I'm making circles, and they're being stacked from here, 0, to there, 1, so from 0 to 1. My outside edge, so our circles, pi r squared, and then I have to subtract the inside edge, which is the space I don't want. So that's going to be like this piece right here, okay? So this is my outside edge. This is the inside of that region. So, you know, top and bottom. So that's that region right there, okay? So this is the quadratic. So it's going to be y squared minus 1. Subtract the axis, which is negative 2. So subtract negative 2. Notice that will make it a positive 2. Okay? Then I want to get rid of this area right in here. So let me just show you what that will look like. So to get rid of that area right there, I use my inside curve, which is this one, and the bottom of it. So that's the top, bottom, that's the region I want to get rid of. So the top is just negative 1 minus my axis of rotation, which is negative 2. And notice when we clean that up really quick, that's going to be plus 2. So negative 1 plus 2 is a positive 1, and that's what the radius is the entire time in that little section right there, right? So this is, first off, I've got to put parentheses around that whole thing because my dy needs to be multiplied to the whole thing. So now we just type that into our calculator, and we get 2.7227. So you can do 2.722, or you can round it up to 2.723. All right, problem number 11. Looks like we are once again rotating parallel to the y. So this is going to be, everything's going to be in terms of y. Okay. Our region is right up against our axis of rotation, so we don't have any holes, any little gap there, so we don't have to worry about that. So let's see, as this thing gets rotated around, this is the kind of a shape I guess it's making, right? So these are how our circles are being stacked. Being stacked from 0 to 1. We're making circles, so we're adding up the areas of circles, pi r squared. My equation right here is that's the quadratic, so it's y squared, minus the axis of rotation, which is -1, and dy. Type that into our calculator. We get 5.8643. So 5.864. Okay, problem number 12. This one, we are rotating around an axis parallel to the x-axis. So this is going to be in terms of x. Okay, so as this guy rotates around, he's making shapes like this. The circle's going that way like that. So they're being stacked from 0 to 1. So we're going to do the integral from 0 to 1. We do have a hole inside of our shape. It's not a solid shape. It's it's got So if this guy gets rotated around, it's gonna be like a really thin ring that goes around, right? So I want to find the volume of the outside edge. What's created by the outside edge? So it's gonna be pi r squared, and this is the outside edge. So this is like this guy right here. So there's the top of the outside edge, and here's the bottom, the axis. Okay. So I'm rotating this shape around, creating a nice solid piece of work. Okay. So that is a radical or a square root graph. So that's going to be this guy right here. Square root of x. I'm going to write it as x to the 1/2 power because that's probably how I'll type it into my calculator. Plus 4 minus, so top minus bottom. The bottom is my axis of rotation, which is -1. So that right there will give me the volume of the whole thing. But I don't want the volume of the whole thing. I want to get rid of all of this white stuff right here. So that is generated by this curve, and there's the bottom of it, the axis of rotation. So I need to go minus the circles created by the curve. That's the parabola, so it's x squared plus 4 minus my axis of rotation, which is, once again, -1. And then I need to throw in my dx. Notice my dx has to be multiplied to both of these. So right now it's only being multiplied to this guy. I need to throw a parenthesis right there. And there we go. Type that into our calculator. And we get 11.4144. So 11.414. Okay, problem number 13. Let's zoom this thing down. Okay, here we go. 13. We're right up against this axis. The axis is the x-axis, so this is going to be with respect to x. Okay, we are adding up circles, areas of circles, right? Dx from 0 to 1, and our radius is going to be the top, which is this, minus the bottom, which is our axis of rotation. So it's the square root of x minus 0, and there's our equation, which, if we type it into our calculator, gives us 1.5707. So 1.571 or 1.570 be your correct answer for 13. Okay, 14. Let's see. We're rotating this around the x-axis, so it's going to be everything's with respect to x. We got a big gap in the middle, so we need to find the volume generated by the outside curve first, and then the volume generated by the inside curve, and subtract it from the outside curve. So we are taking the integral from, looks like we're being stacked this way, so -1 to 0. All right. The outside curve, so that's going to be pi r squared. Outside curve is this guy. That's the top of the outside. And there's the bottom right there, so that region right there. So let's see, that's the parabola, which is -x squared plus 7, minus the bottom, which is 0. That's nice. That will give me the volume of this region right here rotated around the x-axis. But I don't want that whole thing. I want to get rid of the volume generated by that region right there. So I want to get rid of that. Once again, we're making circles, So pi r squared, that's the top, which is that line right there, negative x plus 5 minus the axis, which is 0. And this is in terms of dx. So let's see, I got a parenthesis right there. I need a parenthesis to close it off, dx. Type that into our calculator, and we get 44, there's my thing, 44.6106. So either 44.610 or 44.611. Okay, let's look at 15. Here it is right there. So we are rotating around a line parallel to the y-axis. So this is going to be in terms of y. We do have a pretty big gap, so we'll have to do the outside curve and minus the inside curve. So here we go. So we're stacking these things from 0 to 1. My outside curve, making circles, pi r squared, minus my inside curve, pi r squared, dy. So my outside curve, which is generated by this right here, getting rotated around my axis of symmetry. So I'm looking at axis of rotation, excuse me. So I'm looking at that region right there. Sorry, I should have probably drawn, I don't want to confuse you with other things I've done. I should have drawn those lines this way. Not that it matters, but so like that. So I'm rotating that around. So my outside equation is negative 4 minus my axis of rotation, which is negative 1. My inside, I don't want this white piece right here, which is bounded by the quadratic on the top. So negative y squared minus 3, subtract my axis of symmetry, which is negative 1. And there's our equation. Type it into our calculators, and we get 10.8908. So you can put 10.890 or 10.891, either one. Okay, problem number 16. So it looks pretty good. We got kind of a big gap right here. So we're rotating this around that. It's parallel to, actually is the y-axis, so we're dealing in terms of y. So I want to take the area generated by my outside curve, so pi r squared, minus the area generated by the volume generated by my inside curve, so pi r squared of my inside curve. And this is with respect to y. We are being stacked from negative 1 to 1, negative 1 to 1. My outside region, so that's by the outside curve and my axis of rotation. So that region right there. Top is a parabola, so y squared plus 4, y squared plus 4. And the bottom is 0, so minus the axis, which is 0. And I want to get rid of the inside curve, which is bounded right there. So at 3 minus 0, and type that into our calculator, which gives us 61.9940. So 61.994 is our answer to 16. Okay, 17. Here we go. We're taking that little thing and spinning it around this axis right here, x equals negative 2. It is parallel to the x-axis, so these are going to be in terms of x. I'm going to have kind of a gap here. So what I need to do is find out the volume generated by the outside of my shape, pi r squared, minus the volume generated by the inside of my shape, pi r squared. It's dx. So we're stacking it from here 0 to 2. So my bounds are 0 to 2. My outside shape is that straight line right there. So that's going to be 2x minus 2. So 2x minus 2 minus my axis of rotation, which is negative 2. So there's the outside. And then my inside is this guy right here. So I want to get rid of this space right here, right? So to find that volume, it's this curve. The top part is parabola, x squared minus 2, minus the axis of rotation, which is also negative 2. Type that in your calculator and get our answer. And we get 13.3 13.4041. So 13.404. All right, problem number 18. We are rotating it around an axis parallel to y, so that's dy. We will have a gap, so we're going to do the integral from our outside curve, the region or the volume generated by that region, the outside region, minus the inside region, and this is with respect to y. These things are being stacked y values from 0 to 2. Okay, my outside curve, the region right here, that's the top of it. Okay, there's the bottom of it. So we're talking about this volume right here as that gets rotated around. So the top, that's a parabola, so it's going to be negative y squared plus 7 minus our axis of rotation, which is 1. And then we need to get rid of, there's the bottom of our region. We need to get rid of that part right there. So it's bounded on top by 3 minus our axis of rotation, which is 1. Type that in your calculator for the answer. And we get 120.6371. So 120.637. Okay, problem number 19 now. Almost there. Home stretch. Here we go. So we are rotating this one around the x-axis. So this is in terms of x. So let's try piecing this thing together. We are going, we do have a gap, so we're going to have our outside, pi r squared, minus our inside, pi r squared. It is in terms of x. We're stacking this thing from -1 to +1. Okay. The outside edge is that against my axis of rotation, so we're talking about that shape, okay, being rotated around. So that's the parabola, negative x squared plus 4 minus our axis of rotation, which is 0. That makes it nice. And then we want to get rid of this space, right? And it's bounded on top by the line 3 minus our axis of rotation, which is 0. And there's our equation. Type it into your calculator, and we get 28.4837. So you can do 28.483, or you can round that up to a 4. All right, last problem. Problem number 20. We're right up against our axis of rotation, so we're not going to have a gap like we did on this one. We don't have to worry about that. So it's simply, we're rotating with respect to this axis right here, which is parallel to x. So this is all going to be dx. So these are x values. We're rotating, let's see, bounded right there to there, so 0 to 2. Pi r squared. My top is the parabola, so x squared plus 1 minus the axis of rotation, which is 1. Oh, that's nice. Those will cancel out. So really, it's just pi x to the 4th. So type that into your calculator. And we get 20.1061. So 20.106 is our final answer. And that finishes us up for this assignment.